Statistical models assume ergodicity by default. They compute ensemble averages and treat them as descriptions of individual outcomes. This assumption is rarely stated. It is almost never verified. The question is not whether ergodicity is a useful property. The question is whether assuming it by default is justified. A process is non-ergodic when time averages do not converge to ensemble averages. The limit either fails to exist or converges to a value different from the ensemble mean. This is not a rare mathematical edge case. It is the structural condition for any process with multiplicative, absorbing, or path-dependent dynamics. Most real processes have at least one of these properties. 3 structural features produce non-ergodicity. First, multiplicative dynamics. Increments compound rather than add, causing paths to diverge permanently. Second, absorbing barriers. A path that reaches 0 cannot recover. Third, path dependence. The future depends on the specific path already taken. Any one of these features is sufficient to break ergodicity. An arithmetic random walk adds independent increments. Its time average converges to the ensemble mean. It is ergodic. A geometric random walk multiplies. Its ensemble average grows. Its median path decays. The ensemble mean is pulled upward by the few paths that survive. Multiplicative structure destroys the equivalence ergodicity requires. Under ergodicity, the ensemble average describes the typical outcome. Under non-ergodicity, it does not. The ensemble average is dominated by a small number of extreme trajectories. The median path behaves much worse than the mean suggests. Using expected value as the relevant quantity under non-ergodicity is a structural error. It describes outcomes that most trajectories never reach. Ergodicity can be recovered under specific conditions: additive dynamics, finite variance, a bounded state space, no absorbing barriers. These conditions describe constrained, constructed systems, physical systems in equilibrium, mathematical models designed around these properties. Most economic, biological, and social processes do not satisfy all of them. Most real processes are multiplicative. Wealth compounds, populations grow or collapse, biological systems absorb damage irreversibly. These are the natural dynamics of systems in time. Ergodicity is not the default. It requires specific structure that real processes do not naturally exhibit. The ergodic case is the exception. Non-ergodicity is the rule.